2018 paper 1, time zone 1, standard level. This question for the IB students. Question 19. A liquid that contains a negative charge carriers is flowing through a square pipe with sides A, B, C, and D. Magnetic field acts in the direction shown across the pipe. On which side of the pipe does negative charge accumulate? Okay, as shown here, the direction of the flow of the liquid with negative charges, they're coming from inside and outward. So the direction of the conventional electric current is going to be in the opposite direction. So this is the direction of electric current. Or the conventional electric current, the flow of positive charges again is opposite to the direction of the negative charge carriers or the flow of liquid. The magnetic field is coming from the right side to the left side. So according to the right hand rule, the direction of the current is inward, shown by the thumb or inside the page, and the direction of the magnetic field is from right to left when you stretch the four fingers. So the direction of the force, or the induced electromagnetic force here, shown the upward. So the correct answer, logically, according to the right hand rule, is going to be upward here. But the question is, why we have an electromagnetic force? The electromagnetic force, or the induced electromagnetic force, is coming from the interaction between the magnetic field, or the external magnetic field here, which is coming from the right to left, which interacts with the magnetic field around the induced, or the electric current, or the charges itself. So we have, as I said again, interaction between the external magnetic field and the magnetic field around the electric current. This is the reason to cause an induced electromagnetic force. So the correct answer finally is A.